Yo, bro, what's up? Good to see you again,
Good
man.
to see you, Nandita. Hello, my name is David Dukes, and I am your host. This is the SciArts Showdown. It's a show where I am joined by a scientist. We interview them and then use their work as a jumping off point for a SciArts project. And then in the end, they review and grade our project. Today I'm joined with Nandita Kumari. How are you, Nandita?
Hi, I'm doing great, David. Thanks for having me. Hello, I'm Nandita. Um, I'm currently a fourth year graduate student at Stony Brook, studying Moon.
Awesome.
What about you?
Moon. Yeah, we've got the moon joining us today. Um, so, Nandita, you're a PhD candidate, right?
Yes.
All right. What does that mean?
So you read so when we grow up, we read a lot of books, science books, math textbooks, even social sciences, and um, all that knowledge is produced via a lot of research,
Mhm.
and that research is being carried out by like mostly PhD students. It can be anyone, but like most of it, like the bulk of it, is being carried by doctorate PhD students. Yeah.
That's cool. And you're one of them. So, how did you end up a PhD student studying the moon?
Okay, so I would like to start by saying that a lot of my peers
Hmm.
have had really long, detailed plans of being a PhD student. I had no such plans. Um, so when I was doing my undergrad, so I'm a engineering undergraduate,
Hmm.
and when I was doing my undergrad, the goal was to pass out of engineering, get a job, earn money. When I was in my pre-final year, I happened to like I was gifted a book by someone. That book was written by Dr. APJ Abdul Kalam. He's a space scientist back in India. He's an engineer essentially, and a very popular one. He's called the Missile Man of India.
Cool.
So I read his book and I was like, okay, this is so cool. I want to maybe try this. And then I ended up doing a couple of internships, and that's how like my path, my life completely changed. And like I ended up, yeah, doing PhD.
That's awesome. So, I read about one of your internships. It was with a former astronaut. Is that correct?
No, it was with a former astronaut, a current astronaut trainer,
Current
not even
astronaut.
trainer, not even like he's not an astronaut. He trains them
Okay.
to like identify important samples and like just decide what the moon is gonna be like. So he's one of those guys. His name is David Kring. He's a scientist, a senior scientist at Lunar and Planetary Institute. Um, he does lunar science. He does a lot of sample science. So he has been in lunar community since Apollo.
Okay.
So he was a student back then. Then there was something called constellation that happened after Apollo, which was supposed to again go back to moon,
Hmm.
but it happened like it just happened to be crossed off eventually, and he was one of the major uh, players in that, where he's trained a lot of scientists, a lot of astronauts to like pick up good samples, identify samples, and like just yeah, how to go around moon, what
Okay.
it's gonna be like, and he still does that.
That's really cool.
He is the guy for like if you ever visit Meteor creative like training field,
Uh huh.
uh, it's very highly likely he will be your trainer.
That's awesome.
Yes.
So, what were you doing in that internship?
Oh yeah, so okay, so let me start. How did I get that? So I came here in 2019 fall, and I finished a year, and NASA has something called survey nodes, which is Solar System Exploration Virtual Institute.
Hmm.
And I think there are 6 survey nodes. One of them is with like Tim here,
Okay.
Tim Glotch, who's my advisor, and the other one is with David Kring. Like of like 6, 2 of these are the ones that I'm mentioning. And I happened to apply for an internship with him because I had heard great things about him, and I wanted to work with him. And Tim was very encouraging about that. So I and then like COVID hit in 2020
Yeah.
during summer, and then nothing was certain because like there was like he sent out an email saying he might cancel the internship because you're supposed to go there
Hmm.
and like work at LPI and JSC, which is Johnson Space Center, and they're pretty close. So you like you work crossly with like people at both the places and like you know get trained and like. But eventually he decided to move on with like a virtual internship, where you like stay locally
Hmm.
and just work. And since most of my work is um, laptop work, I would say like a lot of image processing, I do very limited sample science.
Hmm.
For me, it wasn't like very difficult. So that's how I ended up, and yeah, ended up working there like with him
That's
with LPI.
that's really cool. So what you work a lot on the computer, right?
Yes,
What do you do on the computer in relation to the moon?
that's a good question. Thank you for asking that. So, okay, let me start by saying I do lunar geology.
Hmm.
Now, when we hear the term geology, even my friends, like the first thing that comes to your mind are rocks.
Hmm.
And you're like, okay, but geology, and we have rocks
Yeah,
in the background.
exactly. These are actually yeah,
Uh, and there are several ways of studying rocks,
yeah.
right? You can use the samples that we have here, like you can pick a rock and do like sample analysis. But again, from extraterrestrial planets like Moon, Mars, and places like that, we have samples from Moon, but we don't have samples from many other places. You
Hmm.
know, like Mars or like Europa or several other planets, Venus, Mercury. In those cases, we use electromagnetic spectrum to study the rocks.
Okay,
So essentially, I'm using like physics and chemistry combined to
okay.
study geology.
What do you mean when you say the electromagnetic spectrum of the
Okay,
rocks?
that's cool. So everything,
Hmm.
everything you, me, um, this rock, that globe, has its own signature in every wavelength, which is like our electromagnetic spectrum is made of like different wavelengths. So we can only see from 400 to 700 nanometers, which is like the visible wavelength in which we see everything. But there are wavelengths which exist beyond like both the sides. Like there are wavelengths before 400 and there are wavelengths after 700. And like there are reflections and like emissions in those wavelengths, and we use those phenomena to understand like what kind of rock is present, how it might have formed
Okay.
there.
So essentially it's light, right?
Yes,
Cool. And you are looking at the light that's shined on the moon?
yes,
Yes.
that's
Yeah.
correct. I'm essentially looking at the light that is being reflected or emitted by lunar surface.
Okay. So what can that tell us?
It can tell us a lot of things. It can tell us what it is made of, um, and like also it can just tell a lot about resources there, like if there is water present, because like water has this distinct signature. um, it can tell us like how different materials behave.
Hmm.
Is it similar to earth, because moon doesn't have atmosphere, so like even mercury doesn't have atmosphere, so how are these places different?
Hmm.
Um, and like even absence of light can tell us a lot of things.
Really?
So like yeah, we not only look at like daytime electromagnetic spectrums, we also look at nighttime things. So, for instance, during nighttime, it's very useful to understand what is the rock distribution, because rocks are hotter, so they remain warmer at night. So they like appear as this distinct like hot surfaces which are rockier. So, like yeah, light presence and absence both can tell us like a lot of things.
That's awesome. I know you
Yes.
mentioned before this machine learning. What can that help us uh, know more about this light reflecting and absence on the moon?
Yeah. Thank you for bringing that up. Okay, so before we get into ML,
Yeah.
one thing to understand is as we send more missions to different planets, including Moon, the bulk of data we are getting is huge.
Yeah.
Like we are getting terabytes, zettabytes of data. And Moon is a very small body compared to a lot of other planets like
Right.
Jupiter or like even Mars. Mars is relatively bigger than Moon.
Hmm.
Um, and it's it will only increase. It's not going to decrease. Like the
Yeah.
data we'll be getting will increase, and like because you're trying to get like better and better data, and better and better data means like higher volume.
Hmm.
And eventually, I think we're already at a point where we cannot look through all of that individually as human beings,
Oh,
because we can
absolutely.
only do so much. And that's where like I think like automation and machine learning comes into play, where you're like you are not going to like do all of it by yourself. You're going to teach your computer how to look at it for you, and like you're going to teach your computer what are the things you're interested in to identify those things for you, and then
Hmm.
like you can add a human component to it, or you can like completely automate it. So
Hmm.
right now, what I'm doing is um, I am teaching my computer to identify certain features which will help me understand the composition of moon in a more accurate way
Okay.
than we do currently.
Okay.
So there are certain features on moon from where we do not have samples, but they are very weird. And those features are like they are silica rich volcanoes on moon.
Okay.
So moon is essentially made of uh, a rock called basalt. It's a dark rock. So if you see the face of the moon that we see from Earth on the near side, it's darker because of that rock, and
Hmm.
the other side, which you never see because of the tidal locking, is brighter. If you ever happen to look into an image, you should like everyone should definitely go to this site called LROC, LROC Quick Map, and you can look at moon at the finest resolution there, and
Yeah.
it's accessible to everyone. Um, so the like and on this darker side, like on this darker patch of the moon of the near side that we see, we find these really weird volcanoes which have very different compositions
Hmm.
from like the area around them.
Hmm.
And then you're just like, but how did these form? Because it has to be the same magma source. And if the magma source is same, why is this composition so different? And they also form in very different environments on Earth. So what does that tell us about moon? uh, but right now, until now, before like my project, we only knew that they are different. We had a slight idea of how different,
Okay.
but we weren't very precise about this is SiO2 8% 10 and this is SiO2 8% 20. We would be like, oh, this is higher, this is lower. So we know this is lower, this is higher, but we can't put a number on it. So my project is to put a number on it, that
Okay.
this is what it is. So that's where ML comes in. So I'm putting a number on things and being like very accurate about things.
That's cool.
So yeah.
And knowing these numbers, the percent of silica and what the composition of the rock is on the far side of the moon, how might that help us in the future?
Okay, so first, there are several things to it. First is like the scientific outcome.
Yeah.
Moon is our window to the past. What because like the scientific consensus is that moon formed from Earth. Eventually, it's a part of Earth. So what? And it hasn't evolved much like Earth. And by
Hmm.
that, I mean it has evolved, but like not like Earth. On Earth, things have been erased by water and wind. On Moon, they have just remained that way. So it's like looking into what Earth would be like um, during those times. So that is past just for like scientific understanding of like putting together the pieces of a puzzle, but also for like future. So I'm saying this because as we go forward, we are looking for resources outside Earth, and knowing the compositions help us determine the resources.
Okay.
So knowing the composition, knowing if there is like radioactive material present, what's the composition, how much can we like mine it,
Hmm.
if we can mine it, like how much will it cost, will it be worth the cost, and like stuff like that. Like all that comes from composition. So
Hmm.
going future, like knowing all the extraterrestrial resources to like, I don't know, I really want to see intergalactic travel before I
Yeah.
die. And if
That'd be
that
so
has to,
cool.
yeah, and if that has to happen, we got to stop taking everything from Earth. Like we got
Yeah.
to find other places from where we can use it. And Moon is a very close by place where we can like test our things really quickly and then like move further out. So yeah, that is for the future, like identifying and knowing how to utilize those resources.
So in the future, would you like to see a moon base or people living on the moon?
I would absolutely love to see a moon base for
Yeah.
scientific experiments. I i am not a big, I'm not like very supportive of the idea of settling on moon or
Right.
colonizing moon.
Yeah.
um, as like human beings,
Hmm.
um, I think it's essential that we go beyond Earth and explore what is out there, because I think Carl Sagan or someone has said that we are universe's way of knowing itself. So
Hmm.
we have to look at things outside. Um, but at the same time, I think the idea of settling on another planet comes associated with the idea of like just draining Earth and not doing anything
Right.
towards what we are facing, the climate crisis and everything else.
Absolutely.
And I absolutely abhor that thought process?
I am an environmental scientist, and I'm so glad you bring that up because that's something that I deal with a lot. Is I look at all the contamination that is present on Earth, and I try to figure out where it is, where it's going, and how to deal with it. And then I feel like that isn't as popular as the space science, and everyone wants to leave Earth but not address the problems that are here.
Yeah,
So,
because so there are two aspects to that too. One is like we have taken millions of years to evolve here to be accustomed to this climate, and you suddenly just want to like drain it, like destroy it and leave it.
mm-hmm.
First is like that's running away from a problem we created, and this, if we run away from this today, even if we end up on another planet and we get accustomed to it, which is highly unlikely, but if it happens, um, we are going to create the same problems there too. And how
Yeah.
many times do we change the planets? Like we
Yeah.
can't do that. Second, like this is home, irrespective. I think you will barely meet a space scientist who will ever tell you that, oh no, we should totally leave Earth. These are like the people who have never looked at moon. I look at moon every day,
Mm-hmm.
and I see how dead it is.
Yeah.
Like studying moon has made me love our Earth a lot more, because like it's beautiful. There is life around, there is light, there are green plants. Like I just cannot emphasize enough like how much we should like protect our home. Like yeah.
Absolutely.
Yeah.
Yeah.
So I see the idea of like doing scientific experiments and like everything else, like in case some like natural phenomena of like a really large asteroid or something hitting us happens, and we have to like somehow prevent our species from like extinction. It's good to have like those things ready,
Mm-hmm.
but that shouldn't, like the thought, like the end goal shouldn't be running away
Yeah.
from Earth. The
Absolutely.
end goal should be to like have a backup and be knowledgeable about it, not to like drain this planet and
Mm-hmm.
like yeah, just leave.
Absolutely. Yeah. Thank you. I know in your news article for Stony Brook University, one of the things that you discussed was women in STEM and getting more women involved in STEM. Would you like to talk a little bit about that?
Yeah, absolutely. So I think there should be like um, so there are definitely more women in STEM compared to like a couple of decades ago, I would say. But we still need more women in STEM in general because of a few things. First is when you are trying to hire more people like me, I need someone to look up to.
Yeah.
I need someone to relate to.
Mm-hmm.
Like like when I was writing my statement of purpose, right? I asked my friends to like send me their grad school statement of purposes when they were in grad school. And they all wrote this letter about how they have been passionate about something ever since their childhood. And I couldn't relate to that at all because I was not passionate about this thing ever since I was born. Like,
Mm-hmm.
I just happened to like stumble across it and fell in love with it. And so I didn't find anyone relatable there.
Mm-hmm.
And it's a similar story when I came in. Like, if I don't see someone like me around, it becomes hard to see myself in that position too. So you need more women for that. And like when you have more women, that's when like you'll the best way to like tackle gender disparity is to get women in those positions who understand our problems instead of like men or like anyone else literally creating like the problems for us and then like solving it through their lenses.
Right.
So, and not just women, I think we need a lot of LGBTQ folks, a lot of people of color. um, STEM is very wide. Geology is very wide. Like I don't know about
Yeah.
STEM, but geology is definitely very wide
Yeah.
in US. And I would like to see more people like me in there. Like I mean, I think the biggest conference that is in planetary, which is Lunar Planetary Science Conference, when I go to, I think I know almost every person of color. That is how small the number is.
Yeah.
Like we all know each other mostly, all the people of color across an entire freaking domain, which is like that's really small. We need more people. We need enough people to not know each other and be like,
Yeah.
oh, I've seen
Yeah.
you for the first time. Who are you?
Yeah.
So yeah. Um, And I think growing up, one feedback that I got a lot from my neighbors, a lot from my relatives, thankfully my parents were really nice about it, was like women are raised back in the society I come from to be servers
Mm.
to men, to society, to their family. We are raised to be subservient to their needs, their demands. Is problematic at so many levels because we are our own human beings, but also like, yeah, it's just, I'm so glad my mom taught me to have my own identity and be like, no, you're gonna, like, you're not gonna be like someone's, like,
Yeah.
like someone's servant, or like depend on someone for anything. Like that's why even when I joined engineering, the whole plan was to like get a job, have my own money,
Yeah.
so that I don't have to like depend on anyone financially. And I think financial independence gives you a lot of other kinds of independence. Like that's, it is one of the most important independence to have, to be able to take care of yourself, to be able to feed yourself and meet your own needs. And I
Yeah.
think STEM is a way to do that. Like education is a way to do that. STEM
Yeah.
is the highest
Absolutely.
paying part of education, so just join STEM.
Yeah. Yeah. Awesome. Well, thank you very much, Nandita. Is there anything else you would like to tell us today?
Yeah, I think I would like to tell a couple of things. One is, uh, when you see someone who is really good at anything,
Mm-hmm.
be it science or sports or anything, there's a lot of talk about that person being talented.
Mm-hmm.
And I don't know, I just wanna like break that open, that it's not always talent.
Yeah.
That like getting better at something takes a lot of hard work. So if you are worried that you might not be as talented as someone to get somewhere, don't be.
Yeah.
Like we all start from scratch. Trust me, I still have days where I'm like, oh my god, what am I doing in life? Like this is all bad. I don't know this. And
Yeah.
I gave a talk today in which I said I'm stupid across like an entire audience because I made some very silly mistake while speaking. And
Mm.
it happens to all of us. And I've heard like the best scientists like having those moments of questioning everything in life. So don't be worried, just like go for it. Like try hard, but like
Yeah.
don't let those failures stop you. And this is especially for women because like women are especially taught to give up
Mm-hmm.
after the first few failures. Like you're not as smart as men, or like, so don't. You are
Mm-hmm.
just like not, you're just not as encouraged as men. They are failing too, trust me. They fail
Yeah.
so many
I fail
times.
all the time.
Yes, they fail as much as us.
Yes.
They just like get that encouragement, and we oftentimes don't. And so don't worry about it. You're not doing it wrong. All of us have failed several times before getting to where we are, or before trying to get to where we want to get to.
Yeah. Yeah.
Yeah, that's pretty much it.
Thank you. Yeah. Science is hard, and experimenting in itself is learning from failure.
Yes.
Yeah.
Yeah, I
And
agree with that.
it can be tough.
Yes,
But
that's how life works. You learn and you fail and you learn.
exactly. Yeah. Well, thank you very much.
Yeah, thanks, David.
Yeah.